So this is the back substitution as well as the solving when we have 3 equations with 3 variables. So first of all, when we have back substitution, what do I do here? How do I go about solving this type of set of equations? We're going to plug in 9 for z. We know that z equals 9 here. So I'm going to take 9 and I'm going to plug it in for my z value. So when I do that, I'm going to take the second equation. I have y plus 2 times 9 equals 9. Does anybody have any questions about that? We're okay? Okay, so now let's just simplify. Y plus 2 times 9 is 18 equals 9. We're going to subtract 18 from both sides. And you get y equals what number? Negative 9. Very good. So that's going to be my y value here is negative 9. Now I'm going to take y equals negative 9 and z equals positive 9, and I'm going to plug that into this top equation so I can find out what x equals. So I have x minus, my y is negative 9, plus 5 times z, which is positive 9, equals 41. If I have x minus the negative, that's going to give me plus 9. 5 times 4 is 45, so plus 45 equals 41. What is 9 plus 45 equal? 54. Good. Equals 41. Now we subtract 54 from both sides. And I get x equals how much? What's 41 minus 54? Negative 13. So this is the x value that I found, this is the y value that I found, and this is the z value that I found. So that is my ordered triple. And some of your homeworks that you guys turn in, I went back and I wrote, make sure you answer or write your answer as an ordered triple. Don't just leave x equals, y equals, and z equals all over the place. You need to write it as an ordered triple. Now we can go back real quick, we can take our calculators, and we could say, all right, let me check. So if I plug in negative 13 in that first equation, negative 13 for x, then I have minus, and then I say negative 9 for y, plus 5 times positive 9, and I hit enter, I get 41. Does 41 equal 41? Yes. So let's go to the second equation. I'm going to put in negative 9 for my y, plus 2 times 9, and I hit enter, and I get positive 9, which is exactly what the second equation equals. So we know that our answer is correct. Anybody have any questions? We're good with that? All right, let's look at the second one. How is this one a little bit different? How is number 2 or whatever, this the second equation, second problem, how is this a little bit different? Because z is negative. We don't want to leave our variable as negative, so I'm going to go ahead and divide this side by negative 1 and this side by negative 1. And I get z equals positive 1. You should always go ahead and do that, guys, if you can. If your z equals is negative, you want to go back and make it a positive. So we're going to find the x value, y value, and I already know what my z value is. So I'm going to take this z value right here, and I'm going to plug it in to this equation, the second one. So I have 2y plus 8 times 1 equals 8. Now what? What is 8 times 1, guys? 2y plus 8 equals 8. If I subtract 8 from both sides, I get 2y equals 0. Now going through some of your homeworks, I don't have many of you left, so these things stood out in my mind. I had a couple people that stopped right here and said no solution. If this was no solution, it would say 2 equals 0. And then you guys would say, oh yeah, no solution. But that's not what this problem says. This is still an equation that I can solve. How can I get y all by itself? Divide both sides by 2. Good. So when I divide by 2, I get y equals how much? 0. That is an okay answer. You can have the variable equal to 0. So my y value here is 0. Now I'm going to take this y value and I'm going to take my z value, plug it into the top equation, and figure out what x is. So I have 4x minus 3 times y is 0 plus 15 times 1 equals 3. All right, so if we simplify here, negative 3 times 0 is 0. 15 times 1 is 15. So you have 4x plus 15 equals 3. We're going to subtract 15 from both sides. and we get 4x equals negative 12, right? Divide both sides by 4, and we get x equals negative 3. So I can go up here in my ordered triple, and I can say x is negative 3. Now let's take just a second, grab our calculators, and plug back in and see if we are correct. So in the first equation, I'm going to say 4 times negative 3, because that's what our x value was, minus 3 times 0, plus 15 times 1. And when I hit enter, what should it say in my calculator? All that stuff combined should equal how much? What's the top equation set equal to? 3. And it works. So we're good to go. So that's what your back substitution should have looked like last night when you guys turned it, or yesterday when you guys turned it in. If you didn't finish the problem, I didn't give you full credit, stuff like that. So now, looking at this, these two equations are due tomorrow morning. So if you follow along with me and write them down, you can then submit it, and you guys will be good to go for your homework. Again, we're going to practice this more after your quiz on Thursday. Our quiz is just on solving nonlinears and on partial fraction decomposition. So this stuff that we're doing right now, this multivariable equation solving and back substitution, is not on your quiz. But what is the rule? What I tell you guys the rule was yesterday, your first equation has to start with what? What's our first equation have to start with, guys? A positive 1, x. Does the first equation right now start with positive 1x? No. Is there an equation in this set of 3 that starts with a positive 1x? Yeah, the second one or the third one. Doesn't matter which one you use, just move one of them to the top. So I'm going to rewrite this as x minus 2y minus 3z equals 4. And then it doesn't matter how you write the rest of them. I'm just going to write the top one underneath. So 2x plus 4y plus z equals 3. And x plus y minus z equals negative 1. So in looking back and talking ourselves through working this problem out, does my first equation now start with a positive 1x? Yes. So I can rewrite it over here in my bracket, and that's going to be my first equation. My first equation, when we're solving, remember, we're trying to get this into back substitution form. So my first equation should have 3 variables, which it does. What should my second equation in my brace, or my bracket, whatever you want to call it, what should my second equation have? How many variables? 2. So we're going to take the first and second equation and cancel out what? Cancel out x's. So I have x minus 2y minus 3z equals 4. And then I have 2x plus 4y plus z equals 3. What am I going to multiply my top equation by so that my x's will cancel out? What kind of 2? Negative 2. Good. So I'm going to multiply here, 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 and all the way to the other side. Which you do to one side of the equation, remember you do to the other. So I have negative 2x, negative 2 and a negative 2y gives me positive 4y. Negative 2 times negative 3 gives me positive 6z. And negative 2 times 4 gives me negative 8. Did I make any mistakes or anything there? We're good? Okay. So my x's will cancel out. What's 4y plus 4y? 8y. What's a positive 1 and a positive 6? 7z equals 3 and a negative 8 is negative 5. So now my second equation is 8y plus 7z equals negative 5. You guys with me? Yes. You could. Yep. Hannah asked the question, how come you didn't put the third equation on top? You absolutely could have. Is that what you did? Okay, yeah, you can. As long as the first one starts with your positive x, it doesn't matter the order. You'll still get the same answer. All right, so now, guys, we have to find our third equation, which should just say z equals. So in order to do that, we have to do 2 things. We have to take the first and the third equation and eliminate our x's. And then we'll take what we have left over with our other yz equation, cancel out the y's, and find out what just z is. So I'm going to take this top equation, x minus 2y minus 3z equals 4. and x plus y minus z equals -1. So what would I have to multiply one of my equations by here in order for the x's to cancel out? -1. I'm just going to go through and change the signs of everything in the top, right? I'm multiplying by -1. So if I multiply positive x by -1, it becomes negative x. Negative 2y times -1 becomes positive 2y. Negative 3z times -1 becomes positive 3z. -1 times 4 becomes -4. You guys agree? Okay. So now my x's will cancel out. 2y plus 1y gives me 3y. Positive 3z minus 1z gives me 2z. And -4 and a -1 gives me a -5. Am I done? Do I now have one tiny little equation that says z equals? Not yet. That means I have to take over my two leftovers here that only have two variables. I'm going to combine them, cancel out the y's, and then I'll know what z equals. Doesn't matter which one you write first, which one you write second. I'm just going to write 8y plus 7z equals -5. And then 3y plus 2z equals -5. So this one's a little harder. I have to get my y's to cancel out. What number would I have to multiply by the top and another number by the bottom so that my y's would cancel out? What number can both 8 and 3 make? 24? Okay, so if I multiply the top equation by a -3 and the bottom equation by 8, will that give me a positive and a negative that my y's will cancel out? Okay, so let's go through and do that all the way through, every single thing on either side of your equal sign. So I have -24y minus 21z equals 15. So now I take my 8, do the same thing. So 8 times 3 is positive 24y. 8 times 2 is plus 16z equals 8 times -5 is -40. So my -24y, positive 24y cancel out. What is -21 plus 16? Is that going to give me a -5? Okay, -5z. And then what's 15 minus 40? What is it? -25, good. So now I take one more step. I divide both sides by -5, and I get z equals +5. So I come back way up here, and I have z equals 5. Do I have an ordered triple? Do I have an answer here that I know what x is, I know what y is, I know what z is? No. We know what z is, but we got to find x, we got to find y, and we know that z is 5. So this is where we use our back substitution. I'm going to take this z right here, plug it in here. So I have 8y plus 7 times 5 equals -5. It's +5, right? Down here, yeah. So 8y plus 35 equals -5. I'm going to subtract 35 from both sides, and I get 8y equals -40. Agreed? Are we good? Okay. Divide both sides by 8, and I get y equals what? -5. Okay. So y is -5. And now what do I do with y and z to find x? Plug it into the top blue one, right? So I have x minus 2 times -5 minus 3 times 5 equals 4. So x, -2 and a -5 is +10. -3 and a +5 is -15 equals 4. We good so far? So x, what's 10 minus 15? -5 equals 4. What do I do to both sides? Add 5. And I get x equals how much? 9. So x equals 9. Here is my answer, guys. This is my ordered triple. But in order to get to that answer, there is a lot of work that has to be done in order to get there. So just make sure you guys are showing me that. You're working through the problems and showing me how you get your answers. Now take 2 seconds, take your calculator. We're going to plug in our answer to all 3 equations and make sure they satisfy. So I have in the first equation 2 times positive 9 plus 4 times negative 5 plus 5. That should equal 3 when I hit enter, and it does. So now secondly, I'm going to say 9 minus 2 times negative 5 minus 3 times 5. When I hit enter, it should say 4, and it does. Now in the bottom equation, I have 9 plus a negative 5 minus 5. And when I hit enter, that should give me negative 1, and it does. So our solution is correct. That's a correct ordered triple. Questions from anybody at home? How you guys feel? Anything? All right, let's solve this next one. And then I want to talk to you about one little thing, and then we'll be done for today. But if you guys notice, what is the rule? What's the first thing we have to make sure of? The first equation that we start off with is what? Positive 1x. Is my first equation a positive 1x? Yes. So we're good to go. Let's rewrite it. X minus 2y plus z equals 0. So now I need my second equation to say just y and z. So I'm going to take the first and the second, and I'm going to eliminate x's. So x minus 2y plus z equals 0. 2x plus y minus 3z equals 5. What would I multiply my top equation by so that my x's are going to cancel out? Negative 2, great. So remember, when we distribute to everything on both sides of the equation. So I have negative 2x plus 4y minus 2z equals 0. X's are going to cancel out. What's 1y plus 4y? 5y. And then a negative 3 and a negative 2 gives me minus 5z equals what? 5. What do you guys notice about that? They're all 5s, right? Do you think I could take out a 5 and it'd just be y minus z equals 1? Yes, you absolutely could. If you guys see that you can simplify something like that, you absolutely can. But don't worry, you don't have to. I'm just showing you. 5y minus 5z equals 5. So 5y minus 5z equals 5. So now I need my last equation to just say z equals. So I'm going to take 1 and 3 and eliminate what letter? X. And then I'm going to take my 2 leftovers and eliminate the y's. So I have x minus 2y. Make sure I write this down right. X minus 2y plus z equals 0. 4x minus 7y plus z equals negative 1. What am I going to multiply my top equation by so that my x's are going to cancel out? What kind of 4? Negative 4? Okay. So negative 4x plus 8y minus 4z equals 0. So 4, positive 4, negative 4 cancels out. Negative 7y and 8y gives me 1y. Positive z, negative 4z gives me minus 3z, correct? Equals negative 1. I'm looking for an equation to say z equals. Does it say z equals yet? No. So what do I do with these 2 equations that I have left over? We're going to combine them and eliminate what letter? The y's. So I'm going to just write 5y minus 5z equals 5 on top of y minus 3z equals negative 1. So in this case, guys, what am I going to multiply the bottom equation by so that my y's will cancel out? Negative 5. Very good. And remember, it goes to both sides of our equal sign. So negative 5 times y is negative 5y. Negative 5 and negative 3 is plus 15z equals negative 5 and a negative 1 gives me 5. So this is gone. Combine, the 5y's will cancel out. What's a negative 5z and a positive 15z? 10, right? 10z equals 5 plus 5 is 10. Divide both sides by 10, and what do you guys find out z equals?
1.
Z equals 1. So I'm going to write right here, z equals 1. Did I identify the solution to this system of equations, this set of equations? No. We don't know what the ordered triple is. We don't know what our x value is, what our y value is. We know what z is. We found out that z equals 1. But I have to find out what my y value is, and I have to find out what my x value is. So we're going to use our back substitution. We're going to take this and plug it in right there. So 5y minus 5 times 1 equals 5. 5y minus 5 equals 5. Add 5 to both sides. 5y equals 10, right? Divide both sides by 5. And y equals 2. Now I'm going to take y equals 2 and z equals 1 and plug it into the very top equation to find out what x equals. So x minus 2 times 2 plus 1 should equal 0. X minus 4 plus 1 equals 0. X minus 3 equals 0. Add 3 to both sides. I get x equals how much? 3. So the ordered triple that I just found here was 3, 2, negative 1. Now, is it real easy to make a mistake and put a negative in front of 3 because you just weren't thinking? You messed up somehow? That's why checking is so important, because if you take 2 seconds to plug back in, you don't have to write anything down. Just take your ordered pair and plug it into each equation and make sure that each answer satisfies each equation. So I have 3 minus 2 times 2 plus 1. When I hit enter, that should say 0, and it does. So now we take our second equation. I have 2 times 3 plus y is 2 minus 3 times 1. And when I hit enter, it should say 5 in my calculator, and it does. And then my last equation, 4 times 3 minus 7 times 2 plus 1. When I hit enter, it should say negative 1, and it does. So this is the correct ordered triple for this problem. Does anyone have any questions? All right, something I would like to bring to your attention. We're not going to solve this, but say you have a set of equations, and it's 7x minus 3y plus z equals negative 1. And then you have 4x minus 8y minus 12z equals 24. And then negative 2x plus 5y minus 10x equals 50. All right. What is the rule to solve multivariable equations when you have three equations and 3 variables? What's the rule I told you? Have to have a positive 1x. Okay. There is a way to solve when you guys don't have a positive 1x. We're not going to get into that. We're just going to always work with where we can get. But is there anything I could do to any of these equations that I could change one of them so it says positive 1x? If I took that second equation and I divided every term by 4, watch. Divide by 4, divide by 4, divide by 4, divide by 4. This equation becomes x, what? Minus 2y minus 3z equals 6. Do I now have a positive 1x where I could go about and solve this problem? Yes. So don't just say, oh, none of them, there's no x, positive 1x, I can't do anything. That's not necessarily the case. All right, you have to make sure, go through and make sure you can't simplify. You can't take out a GCF or anything to create an equation that has a positive 1x as a coefficient. We good? Okay, I will.